Welcome, listeners, to our next topic of discussion on the fourth agent of erosion, that is glacier. And after stream with after your mass wasting that is happening under the action of gravity, followed by streams and rivers, and also wind. Now you have the fourth kind of agent, that is glacier. And this is in our series of discussion on fundamentals of geology. So glaciers, obviously we always refer to glacier as the solid ice. So we'll see that how this solid ice form, how it can erode material from one part to another part on the surface of the earth, and it can transport material from one part to another and finally deposit it as well. So again we'll be looking at the you can say the erosional feature of a glacier, then transportation, and your depositional landforms formed as a result of glacier. But first, to have an idea about the glaciers that are present on the earth, which are kind of permanent in nature. So there are zones like that of in parts of majority part of Greenland, part of the Himalayan and the Tibetan plateau. Then you have the Andes mountain belt, and also the basin rich province in your USA, some parts of Canada as well. And also the largest ice sheet we can think of is on the continent of Antarctica. And the continent of Antarctica actually covers or volume wise it is approximately about 80% of the whole volume of the 100% of the glaciers that are present on earth. 80% of them are in Antarctica. Why we are saying this? Because here whenever we are referring to glaciers, we will look for the ice as a result of freezing of your fresh water, not salt water. Your salt water ices are also present in the Arctic region, some parts of Scandinavia as well, and obviously the Arctic region mainly, but that is mainly your salt water that has freezed over the time. But in case of glacier, we will be mainly talking about continental glaciers, means the glacier or ice sheets that are present on your land masses, and which are again strictly which are freshwater equivalent, means the fresh water that freezed into ice will be considered under glaciers. So to introduce a glacier or glaciers first, a glacier is a large long-lasting mass of ice formed on land that moves under its own weight. It develops as snow is compacted and recrystallized. Glaciers can develop in any place where over a period of years more snow accumulates than melts away or it's otherwise lost. Distribution of glacier, like I mentioned, glacier occur in temperate as well as polar climates like that of Antarctica, that is sitting at the South Pole. They are found where more snow falls during the cold time of the year that can be melted during the warm months. So that's a very clear idea about what glacier is. So apart from these areas, they are also found in areas which have extreme elevations like that of the Himalaya or the Andes mountain belt, and of very few parts in Africa as well. So obviously these ice sheets or ice are considered, or snow will be considered under glacial. So how glacial ice actually form? So if I look at snow only, then I'll not say that it's glacial ice. So if there are several or millions of particles of snow are falling on the surface of the earth during an event of snowfall, then what happens? Then a process that is known as the sublimation, and that is followed by recrystallization, will finally form what a glacial ice is. So if I simply think of two ice cubes in my hand, and if I keep it together and kind of press it, then what will happen? That under that pressure, when the two ice cubes are kept in contact with one another, so at the contact region, the ice will start to melt under the action of this pressure that is induced along this contact. So what will happen? That after this, again, if there is a process of freezing, then this melt that is being generated due to the pressure exerted at the contact between the two ice cubes will get recrystallized again to what we now consider as your glacial ice. So your particles of snow simply behave in the same manner. They get attached to one another, and under the process, in grain boundary pressure will increase between the individual grains of the snow, and that will form smaller fragments of snow, that is firn or neve, and that will go into melting at the grain boundaries, resulting into the recrystallization of the snow in form of, during a process of refreezing again, it will finally form what we refer to as glacial ice. So it's a process from the transformation of snow to your what we refer to as glacial ice. So there are various types of glaciers that we can observe in continental land masses. Broadly there are two. One is the alpine type, and the other one will be discussing in a bit. So we start with the first one, that is the alpine, or which are strictly present in the mountainous region, the alpine or mountain glaciers. So alpine glaciers form in high altitude regions on crest and slopes of mountains. They often develop in a valley and flow downhill due to the action of gravity. In high altitude, examples such as the glaciers in Himalayas, Andes, Rocky Mountains, and a few mountain tops in East Africa and Mexico. So there are again broadly four categories of alpine glacier. For the first one is the cirque glacier, where a mountain range has bowl-shaped hollows at the head of the valley. Snow may accumulate to form a cirque glacier. Then you have the valley glacier, like this beautiful field photograph from the Alps mountain belt, where you can see this beautiful valley glacier, that the glacier is flowing in a valley. We'll be talking about the morphology of the valley in a bit, but just to refer here that this glacier is flowing in this valley. So cirque glacier may advance to form valley glacier and may pass below the snow line. Any glacier that sits in an area that has been eroded by stream action can be considered a valley glacier. Then you have your Piedmont glacier, where multiple valley glacier merge and form a reasonably flat stretch of glacial ice, or known as a plain. And also you have this example of tidewater glacier from this field photograph. Again you can see a glacier that meets the sea is known as the tidewater glacier. So remember here I discussed about the base level and ultimate base level of erosion when we discussed about streams and rivers. So if a glacier is down cutting or down cutting the valley floor, we'll be seeing into that how it is a process that involves in the movement of the glacier. So if it is down cutting the valley floor below the ultimate base level, that is the mean sea level, in that case it will be considered as a fjord. So fjords are typically they are glacial which can cut even below the ultimate base level of a region, that is usually your mean sea level. So your tidewater glacial fjords are also an example of this tidewater glacial, where your glacial meets the sea. Then you have strictly continental glacier in flat regions. Not in case of alpine glacier, always there is a factor or a function of slope or gradient is involved, but in case of normal continental glacier, it's an expansive continuous mass of ice considerably larger than that of any alpine glacier. It is known as continental glacier, and that usually develops and moves on a flat surface, or you can say almost horizontal surface. So there is not much of a variation in the gradient or slope of the valley floor. So again your continental glaciers can be grouped into three categories. The first one is the presence of an ice sheet. Again this field photograph, you can see here that an ice sheet is a mass of ice that is not restricted to a valley, it is spread over a larger region. So ice sheets are associated with continental glaciation events. Only two places on earth that now record the presence of ice sheet are your Greenland and Antarctica, like we discussed in the beginning. Then you can have a category that is ice cap, a similar but smaller body is called an ice cap. So ice caps are found in a few mountain highlands or plateau regions in Iceland and on islands of Arctic Ocean, Canada, Russia and Scandinavia. Then you also have the third category, that is ice field. These are again smaller still than an ice sheet and ice cap. In comparison to ice cap or ice sheet, they are further smaller in their dimension, but this fails to cover all of the land. So you can see in case of ice sheet, like we get to see in Greenland or Antarctica, the complete land mass is covered by ice. Relatively less region, when it is covered by a cap of ice, it is grouped under ice cap, but still it is quite large. But if it is very small, then it is only considered as ice field. So you can see it's a function of scale we are dealing with here in categorizing the different types of continental glaciers. Now again, how these glaciers are formed. So like I was mentioning about the sublimation process, so glaciers form from compacted snow. Snow accumulates over time, compressing the layers beneath it. Pressure from the overlying snow causes the lower layers to recrystallize into dense glacial ice by the process of sublimation, like we discussed. So now the gravity pulls the ice downhill, forming glaciers in areas where snow accumulation exceeds the melting of the snow. Glaciers can form in high altitude mountain regions or polar areas where temperature remain constantly low, means below 0 degree over a period or a large period of time. So means again, if I look at this diagram, you can have this several snowflakes that are modified into granular snow. Then you have this fern like, and finally the due to repeated events of refreezing, it is finally recrystallizing and forming the glacial ice. There is also very important consideration like that of we'll be discussing a little bit about the water budget when we'll be discussing about groundwater, but always like it's a cycle of the total volume of glacier that is present on the earth. So that is considered under the glacial budget. It refers to the ratio between positive ice gained and the ice loss. So you can see there is always again a kind of a glacial cycle, that this much amount of ice is getting lost and this much this much amount of ice is again restored to the land. So if there is a positive budget, when a glacier gains more volume during new snowfall than it loses during the melting process, then it will be added to the glacial budget. So it will be positive budget. If you can also have negative budget, when ice lost or melt is greater than ice gained, cause glacier to recede or retreat. So in that case, your glacials with negative budgets grow smaller over the time. In case of your positive glacial budget, the glacial or for example the ice sheet will grow bigger and bigger. And when there is a balance, when the ice gain is equal to the ice that melts. So you can see this graph with increasing amounts of water equivalent. We are using this term water equivalent because obviously ice is formed from water. So if there is a positive balance in the months of winter, in the early months of January, February till March or late March, then you have a negative balance in the period of mainly spring, summer, partially the initiation of autumn, and again after the autumn sets in, again you have a positive glacial budget. So you see this is also going in a kind of a repetitive manner, in a kind of a cycle. There are several zones in a glacier as well. So the first zone that we'll be referring to is the zone of accumulation, where your ice is getting accumulated. So the upper part of a glacier is the zone of accumulation, where your glacial is perennially covered with snow. And there is also the zone of wastage or ablation. The lower part of the glacier is the zone of wastage, where ice is lost or ablated by melting, evaporation and calving. So you can see this in this diagram. This is the glacial ice like this. So this is a snow line below snow line, obviously there is repeated phases of this positive and negative budget, so there will be accumulation as well as there will be melting, so there will be also wastage in ice. So this is the zone of accumulation where your permanently your glacial ice is there, and you have the snow line that separates the zone of wastage from the zone of accumulation. So your glacial ice will be wasted in this zone of wastage during the melting season. Then movement of glacier, remember, if there is a slope, again if I refer to the alpine type of glacier and the continental glaciers, which are definitely which have a very flat or horizontal kind of a surface, what happens that due to the huge load of if a glacial ice has reached a particular thickness, and if it is quite thick, then this thickness of ice will exert a pressure on the surface or the bedrock. So what will happen, the ice that is in contact in contact with the bedrock at the bottom of the glacial ice sheet will start to melt under that action of pressure we was discussing during the process of sublimation as well. So under that pressure, that ice will try to melt, leading to what? Reduction in the friction among friction offered by the surface of the bedrock with respect to the glacial ice. So what will happen, whenever there is a water layer, there will be reduction in cohesion, obviously there will be reduction in friction. So after this, the glacial ice will be able to move from one position to another because of its very low cohesion and friction along the bottom part of the glacial ice. So in case of the movement of a continental glacier where you don't have a distinct gradient, in that case what is happening, it is simply like if I pouring some thick batter of some material, be it for example flour or corn flour I am taking, I am making a batter out of it to fry something. Then if I keeping that batter in a jar and simply I am pouring that jar on the horizontal slab, on your kitchen slab, if I am simply pouring that, so what will happen, the batter will first hit the surface of the horizontal surface, it will hit or the slab, means your kitchen slab you are pouring the batter of your corn flour that is mixed with water. So what will happen, if just after touching the flat slab, it will try to move away from the center of the pouring of the batter. So it will actually move from its center towards its outer part, like we get to see in this kind of example. So in case of an ice, in case of a continental glacier, this is the kind of process that is involved in the movement of a continental glacier from one part to another. So there is load from the top, that is the pouring of the batter, that is load from the top due to the huge thickness of the already existing ice that is present, you are pouring it. So under the effect of that pressure, what is happening, the contact between the glacial ice, the bottom of the glacial ice and the bedrock, it starts to melt. It will lead to loss in cohesion and friction. It will lead to the movement. Finally it will be able to, the continental glacier will be able to move under its own weight due to the loss of friction between the surface or the bedrock. But on the other hand, in case of the alpine glacier, where there is a distinct gradient change over the slope of the mountain, for example, so glacial will also move here by internal deformation of the ice and by sliding over the rocks and sediments at the base. So valley glacier will move downslope under the influence of gravity and their own weight at a rate of up to 15 meters per day. So during this movement there are these three zones: the zone of basalt sliding, about which your sliding is taking place and that requires a gradient; the zone of plastic flow, the ice will slide down or just over the slope like this, so there will be a plastic zone where your ice can move in a plastic manner, like we discussed about plastic deformation in before a few lectures from now. So that is the plastic zone of the ice movement, and the top of the ice will be the rigid zone, and that will behave in a strictly brittle manner. So that's why there the ice, though it is compacted into the snow that is compacted into your ice, will now behave in a rigid manner. And if I want to move a rigid material, what will happen if there is any you can say differential movement, or there is a discrepancy in the movement of the ice due to the movement of the plastic zone, in that case that rigid material will break apart into several blocks, and this breakage in the ice sheet will be considered as the crevasses that we get to see. So sometimes crevasses will not penetrate through the plastic zone, but they could be also quite deep. So this is again a field photograph that you can see the effect or the occurrence of crevasses due to this brittle behavior of the rigid ice that is sitting just over the plastic ice. So now if I look at the movement direction, so the glacial flow in an idealized valley glacier in its longitudinal direction. So if this is the channel through which your glacier is moving, so obviously there will be accumulation area where your snow is getting accumulated, is transformed into glacier, then it will try to settle down there, then it will obviously start to flow. So obviously there will be, whenever it will start to flow, there will be some extension on the upper part of the rigid part of the ice, so that will form some transverse crevasses. Then obviously when it is flowing in a channel, we'll be talking about the shape of the channel in a bit. If it is flowing in a channel, then obviously there will be some differential movement along the boundary of the channel as well as at the center of the channel. So there will be differential movement, and there also you will find this formation of crevasses, but they will be no longer at a perpendicular direction to the movement of the glacier. They will be at some angle because there will be differential movement. So in a channel, whenever be it your river water is flowing or your glacier is flowing, the wave front is in an, you can say, arcuate manner. At the center of the channel, the velocity of the ice will be maximum, or be it river, the velocity of that river will be maximum. At the banks, at the river banks, or at the bounding channel walls, the velocity will be minimum with respect to that particular river or glacial. So in case of the glacial movement, with respect to now the movement direction and the differential movement of the glacier in a channel, there will be marginal crevasses that will also form. Finally, again some longitudinal crevasses will form when the channel will pour near a sea or near a flat land. What will happen? Again, now the velocity of the channel or the velocity of the glacier will be reduced to minimum, and it will try to deposit all the material along its journey to the flat land. So what will happen, that the velocity is getting now dispersed in all the direction, or the movement of the glacier is getting dispersed in all the direction, leading to formation of crevasses longitudinally as well as some of the marginal crevasses will still form. So you can see, so in a channel, when a glacier is bounded within a channel, the movement of the glacial, or the rate of the glacial movement will be maximum. The velocity will be maximum. When it is getting accumulated, it is also less than that of the channel or the central part of the glacier. Also in the front of the glacier movement, or in the front of the glacial ice, the velocity will be also less. So due to this changes in velocity, starting with the accumulation zone, finally to the zone of deposition, within that you have this channel through which it is moving quite fast, you have a change in velocity. Likewise, there is a change in the geometry or the features exhibited on the surface of the glacier. Like this, the orientation of the crevasses will change from a transverse in the accumulation zone, then as your marginal crevasses in the channel mainly, and finally longitudinal crevasses, and where finally your ice is slowing down or finally meeting the sea, for example. So glacial as a geological agent, so glacier also acts as an agent of erosion on land surface, transporting the eroded materials and finally depositing the materials. So transportation by glacial can happen like this. So you can erode material from the surface with the flow of the glacier, because the flow of the glacial will pick up, will be looking at the different kinds of particles getting picked up under the movement of a glacial, but it will pick up the particles or matter that is sitting at the base of a glacier. So it will go on like that. Finally it will deposit all the materials that are being carried by a glacier at the terminal part of the glacier, or what we refer to as the outwash plain. So glacial erosion can be achieved by the four following processes: plucking, abrasion, ice squaring and basalt sliding. So the first mechanism is your plucking. Like this example, you can see that your this glacial ice is moving. So this occur when the glacier's movement causes it to exert pressure on the rocks beneath it, that's your valley floor or your bedrock. As the glacier moves, it plucks rocks and sediment from the underlying bedrock and incorporate them within the ice and flows along with it. So you can see, due to this plucking, it is simply plucking material from the bottom of the glacier. And always remember, these materials or plucking will be restricted to the lower part or the lowest part of the glacier, and the sediments or rock will never come up to the upper part of the glacier. Then you have the process of abrasion. As the glacier moves, it carries a load of rock debris that have been already plucked, for example, due to the movement of the glacier, and this rock debris will be embedded at the base of the glacier. This debris acts like a sandpaper. Simply, if you have a sandpaper beneath your hand, you are putting a sandpaper and you are simply for example, you are moving the sandpaper just over some surface, so even if it is a rugged surface, or even if it's an undulatory surface, due to a long period of this continuous scratching by the sandpaper, it will over the time it will tend to become flat. So this is the bed load of the glacier when it is plucking materials like this, even and making this regolith along with it. Then it will be transported. After plucking the material from the bedrock, it will be transported along with it. So again, this is a kind of you can relate it with the mechanical weathering that is going on, be it your plucking, be it your abrasion. It is the kind of mechanical weathering and followed by erosion, because there is a continuous transport or movement of the glacier that is going on. Then you can also think of the ice squaring, where your ice squaring happens when meltwater seeps into cracks in the bedrock beneath the glacier as the water freezes and expands, because there is always a 10% rise in the density whenever you are freezing ice from water. So there is a 10% increase. So it creates wedges that break off chunk of rock, further contributing to the erosion. So finally, when this glacial for example the glacier retreats or it melts, it can give you beautiful lakes like this. But again, remember, this is very characteristic of your alpine glacials. Then the final kind of movement or erosion imposed by glacial ices are your basalt sliding. This process involves the glacial sliding over the bedrock due to the presence of meltwater acting as a lubricant. So even apart from continental glacier, also in case of alpine in glacier or mountain glacier, also the same pressure is getting exerted between the bedrock and the lowest part of the glacial ice. So that part again will go into melting. Loss of cohesion, loss of friction will lead to the sliding of the whole glacier along its slope. So between the ice, along its slope, or even in case of your continental glacier, in both cases this kind of basalt sliding happens between ice and the underlying surface. So the basalt sliding facilitates the transportation of debris and enhances erosion, thus forming rock flowers. So the rock will be disintegrated into smaller pieces. So here is an example or a block diagram that shows the movement of the glacier, and it is also eroding the surface, the bedrock materials along with it, and it is simply due to this melt water that is present at the contact between the glacier and the bedrock. So here I would like to conclude the first part of our discussion on glacier, different types of glacier and the different kinds of erosion it imposes, and your erosional features that are related to glacier. Next we'll move or in the second part we'll be discussing about the transport and finally the depositional landforms imposed by glaciers. Thank you.